Good afternoon, everybody. Welcome to Tibbetts Physics. What is crappening? You can't see over my shoulder. We got a really pretty sunset going on. Hopefully you get a good quality view. The sky is nice and pink and purple. Kind of matches my tie. Today we're going to introduce Newton's second law of motion. Before we get started, for those that care, I just got back from the dentist and they gave me a clean bill of health. So I thought I'd reward myself with a fresh cup of coffee and a little bit of sugar. Yes, I'll just do a couple of scoops. 1, 2, 3, 4, and 5. Looks like sugar to me. Might be something else. I'm not sure. And one more. Nice and sweet. Okay, so we just finished Newton's first law, and we learned that an object's natural tendency is to keep on moving if it's in motion, or to stay at rest if it's at rest. The problem that we have is friction gets in our way, so it leads to a misconception of Newton's first law. So what we want to do today is let's look at when we have multiple forces going on and to see how that affects an object. So let's say we have Vin Diesel over here. Let me give him some muscles, I guess. And actually he's going to be pushing me, so he'll have both his hands over there. Okay. So Vin Diesel, let's just say he's pushing me to the left, I hope that's your left, with a force of, we'll say, 10 newtons. This is before steroids. So force of Vin Diesel is 10 newtons. And we'll say that there's a backwards force of friction, F sub F, of 5 newtons. Now when he's pushing me with this force, the forces are no longer balanced, so we have unbalanced forces. And what's going to happen when he's pushing me? I'm going to start moving towards the left. Okay. Now let's just say that now he goes on steroids. What's going to happen when he increases the force? We'll say by 10. So now he has 100 newtons of force. So what's going to happen to my acceleration, because the force of friction is not the same as the force of Vin Diesel, what's going to happen to my acceleration? So if the force gets increased by 10 times the amount, so before we had 10 newtons of force, we'll call FV1, and then after we had 100 newtons, FV2. What's going to happen to my acceleration with a greater force? Good, my acceleration should be much greater. So now when he pushes me, I'm going to go flying across the room. Okay, so we could say the relationship between force and acceleration is a direct relationship. So force is directly proportional to acceleration. And we're going to call it F net. The net force. Alright. Now let's go back to the original picture. Oops, sorry. And now Vin Diesel's pushing me with 10 newtons from before. Now this time, let's compare it to the original one of 10 newtons where I just go backwards just a little bit. Okay. Now this time I gained some weight after eating all that sugar, so let's see if we could add some weight to this picture. Let's see here. Okay, can I draw this? Nope, I can't draw now. Okay, so let's just say I gained weight and my mass doubled. Not weight, mass, sorry. And my mass doubled. So now my mass is 200 kilograms. And we'll say before, so mass 2 is 200 kilograms. Mass 1, we'll say, is 100 kilograms. Okay, so when the mass doubles and Vin Diesel is pushing you with the same amount of force, what would happen to my acceleration? Would it increase or decrease? And we should have, or you should have said, that acceleration is inversely proportional to the mass, so 1 over m. If we put these two together, we get Newton's second law, which says that the acceleration is equal to F net over the mass. And again, the net force is all the forces acting on the object in a given direction. We're going to look at these scenarios specifically in class, but let's just do a quick practice examples together. So let's say that we have two objects pushing on a box. One's going to the right with a force, we'll call it F1, of 20 newtons. Oops, just 20 newtons. And one is going to the left with a force F2 of 10 newtons. And the mass of the box is 2 kilograms. And we want to find the acceleration. Okay, why don't you try that first? Alright, so let's see here. Here's the formula. We have acceleration is equal to F net over m. F net is F1 minus F2, because F2 is going backwards, over m, and we'll plug and chug. 20 newtons minus 10 newtons over 2 kilograms. 20 minus 10 is 10. 10 divided by 2 is 5. So the acceleration is 5 meters per second squared. All right. Let's do one more together just to be sure. This time, we'll say the forces are going in the same direction. So we still have our 2 kilogram object. F1 is 20 newtons. F2 is 10 newtons. And we want to find the acceleration. Okay, why don't you try this one again. All right, same thing. A equals F net over m, which equals F1 plus F2 over m, which equals 20 newtons plus 10 newtons over 2 kilograms. 20 plus 10 is 30. 30 divided by 2 is 15. So the acceleration is now 15 meters per second squared. And that's how we find the acceleration of objects using Newton's second law when we have unbalanced forces. See you next time.